All right, welcome back to the Nexus Podcast. Andrew Ohrt is my guest. Andrew is the Resilience Practice Area Lead at West Yost, and we are going to talk about cyber-informed engineering. Andrew has done a lot of good work on this topic, including a talk at the S4 conference earlier this year. So I'm happy he's here to school us and me a little bit on why this concept and this approach matters so much, especially in getting these initiatives off the ground. So I think Andrew's got some good advice on deck for us. Before we start, I just want to thank everyone for listening and supporting the podcast. It's really great to see the growth and engagement we're getting. If you're a first-time listener, subscribe. We're on every platform: Apple, Spotify, Amazon, Audible, you name it. It's really the best way to keep up. I've got a bunch of podcasts already in the hopper. Some I recorded at RSA, others with some prominent folks in the security industry. So it's really the best way to keep up with the show. So I'm excited about what's coming up, and so subscribe and join us. So with that out of the way, let's get started with the episode today. Hey, Andrew, how's it going?
Hi, Michael. I'm well. Thank you.
Tell the listeners a little bit about your role and especially what West Yost is all about.
Sure thing. So West Yost is a water and wastewater engineering company. We've been in business for about 35 years and have around 250 people. And there's a core group of us who are very focused on all things cybersecurity and resilience. And in that journey, about 6 or so years ago, we started to get to know a gentleman who I'm sure many people have heard of. His name is Andy Bachman from Idaho National Laboratory. And as we got to know him and some of the really wonderful people at the lab, we had the opportunity to learn about cyber-informed engineering. And as time went on, we really kind of had the same reaction that a lot of the people that we work with had when we first heard about cyber-informed engineering, which was like, oh, right, that makes so much sense. Let's go do that. And because we had that reaction, we became really, one of the first followers of CIE and started actually implementing it before the cyber-informed engineering implementation guide was out. We signed our first contract to do CIE before that. So we were kind of making it up as we went, as some of these really cornerstone documents and resources were being developed by the lab. And so as we got to know the lab, they said, hey, why don't you come and help us figure this out? And for the last couple of years, it's been just an absolute privilege and a delight to get to work with them and shape cyber-informed engineering for the country.
Yeah, I know that INL especially really champions it, and maybe we should start with kind of a defining cyber-informed engineering. What does it mean to you? What's the kind of the working definition that you guys go by?
Yeah, so the implementation guide has an extensive discussion about what this is, but when we come to this, we really come to it from the perspective of the people in water and wastewater utilities that we work with, which tend to be OT staff, IT staff, and operators and engineers. And so the most simple perspective is we're trying to help the engineers and operators understand what their role is in creating and maintaining a cyber resilient organization. So really, that's the goal of CIE. And there's a lot of breadth to that topic. And, as you may have seen in my S4 presentation, we got it boiled down to some sort of core concepts. It's become pretty effective. And we've seen a lot of our engineers, operators, OT, IT professional clients and customers have that aha moment, just like we did years ago.
And so tell me, what are some characteristics of it? How would I recognize it? What does an implementation look like?
Yeah, so one of the first things is an appreciation for how vulnerable our OT systems are. And also a recognition that if an adversary wants in and wants to do something, they largely can from a technology perspective. And so, that's really the awareness level. One of the things that we have observed is that after that awareness level is achieved, then the engineers have really thought through what we would call cyber-enabled failure modes. And they've said, okay, we understand failure modes. Now we understand that somebody might want to make these failure modes happen. How do we protect ourselves against that? And there's some really good examples about that. Beyond that, then you really get into the breadth of what CIE is and the 12 principles, but that's a really good start.
And what are a couple of examples? What stands out for you? Like, as you're kind of explaining this to maybe a newbie.
Yeah. So when we're talking to engineers, one of the easiest examples is, the inclusion of electromechanical relays to protect equipment, to prevent them from, such things as being started and stopped too much. I've
Mm-hmm.
actually have had conversations with utilities where, their integrator was actually recommending getting rid of relays like that, because those relays do take maintenance and you have to have an electrician to do the maintenance. So why not just put all that right into the code? And when we hear that, we start to get a little nervous, because if it's in the code, it's more vulnerable than if it's a physical non-networked piece of equipment. And so I've had conversations with utilities where they're like, hey, we're about halfway through making that transition from physical gear to those protections being in code, and they actually get kind of upset when I talk to them, and I feel bad, but at the same time, we caught them halfway, so they can stop where they are and still maintain some of those protections without having to spend a bunch of money, or to retrace their steps on the one hand, or build compensating controls in other ways. So that's one great example. We've also seen some really wonderful operational examples from around
Mm-hmm.
the country. The operators, they are oftentimes dealing with imperfect infrastructure in our sector, like many others. Oftentimes that infrastructure is aging. And we have one wastewater utility that I've actually never worked with, but had some wonderful conversations with, where they're very worried about things called pressure transients or water hammer, where if you turn a pump on or turn a pump off or close a valve or open a valve too quickly, it can cause pressure waves within a wastewater collection system or a water distribution system. And if the pipes and joints and everything are not in great shape, it can actually cause ruptures. So,
Sure.
water utilities that I've talked to are very concerned about the possibility of an adversary being able to cause this in their environments. So, some of these operators, they're kind of ingenious. They'll just get like little kitchen timers, and they'll put those on the control panel and say, hey operator, anytime you make a change, you have to set the timer to this amount of time, and you can't make any additional changes until that timer goes off. And it's really just an effort to not create transients within the system that would cause damage. So
Mm-hmm.
that's another really simple practice. Um, we've got a couple others, but the reality is that I think as a sector and as a community of CIE practitioners, we have a lot to discover yet.
Right. Is there a comp here at all to secure software development, or is that just too misleading?
I would probably need to sit down and take a good hard look at software development, secure software
Mm-hmm.
development, to provide you a thoughtful answer, to be honest.
Yeah. 'Cause I mean, like the principles there are just kind of introducing security during the development cycle,
Oh, sure.
enhanced code
Okay.
testing and, before anything goes into production. I mean, obviously it's very different from an engineering point of view, but I was just wondering if there was a comp there at all. But
Yeah, certainly. So when you put it that way, the one of the intents of CIE is to apply the thinking of building cyber resilience across the whole engineering life cycle, from concept to retirement. And in that sense, it's very much the same way. And it's actually been really helpful as we have gone and implemented CIE projects for our clients when we're sitting in the concept phase, or we're just getting into design. And in the water sector, we use something called a PDR, or a preliminary design report. And that's where you kind of say, hey, here are the objectives, here's the initial potential layouts, all those sorts of things. And I've gone through those, and it's pretty rare that cyber of any type is mentioned in those documents. So bringing that forward, creating some focus on it, does allow for the project team to think a little bit differently, account for cyber risk differently, and then ultimately procure services a little bit differently, because that's been another real challenge that we've observed, is that there'll be the designer and then the contractor, and then the integrator will be like a sub to a sub from
Hmm.
the construction contractor, and they're the very last thought on the very last little piece of the project. And
Right.
bringing that forward is really powerful and definitely in the best interest of the asset owner.
How has this been received within the water sector? Because that's notoriously kind of the example. Most of them are very small utilities, under resourced. There isn't a lot of experience with cyber, a lot of manual processes. Just explain that dynamic to me.
Oh, there's a lot to unpack there, Michael. So um, I'll start maybe, let's say, about 8 years ago or so. And we would go and we would talk to a water and wastewater utility about cyber. And I'd say that maybe 5% were like, yep, this is a problem. We need to do something about it. Let's go. Um, in 2020, a good chunk of the sector, probably around 9,000 water utilities, had to comply with the America's Water Infrastructure Act of 2018 updates to the Safe Drinking Water
Right.
Act, Chapter 1433. And we did something like 80 or 90 cyber risk and resilience assessments in support of our clients' pursuit of a WIA compliance. And after that, after pointing out that they had not made the investments that they needed to, we have seen huge action from these utilities, because we have these same compliance dates every 5 years. So here we are in 2025, and we've had the opportunity to do around 20 or so cyber risk and resilience assessments this time. And I will say that the investments that they made have been really amazing and fantastic. Um, the water sector does kind of have a bad reputation in some ways for not taking action. I see it a little differently. And the way I see it is that because we are largely public agencies, we have long procurement cycles and budgeting cycles. And so, like, you and I could go and talk to a water utility today, and they would say, yep, that's a great idea, but we just finished our biennial plan. So come back in 2026 and we'll start talking about
Right.
implementation in 2027. And, a lot of businesses, especially that are trying to get into the water sector, aren't ready for that amount of time for, pursuing sales, right? That sales cycle is a long time.
Hmm.
So, we do, um, as a sector, do a lot of things that are really well. It just, because of the budgeting and procurement cycle, it takes a little bit of time to do those things. You did mention manual processes, and I actually had a really great conversation with a client a couple of weeks ago. So we were doing a series of what we called days without SCADA. And I say days because we went and we talked to the individual process areas about what their capabilities were. And, interestingly, at this organization, some people were very ready to operate without SCADA. And by that, I mean any automation, including the PLCs. It was very impressive. But then we got to one group, and it took us about 25 minutes to sort of get to the point where everybody in the room understood, hey, we're talking about operation without PLCs. And the lead operator said, well, then we're just not making water, you guys. And that was really kind of an aha moment for everybody, and that was really what we were
Right.
trying to get to. Um, and he made a really insightful comment, because this system has been around for many decades, and they've made many improvements over that time. And this gentleman had been there for a couple of decades as well. And he said, every time we make an upgrade, we lose a little bit of that manual capability. And I have sat in many, conference presentations where, someone from a utility around the U.S. is, really proud of their brand new shiny plant that's fully automated, and he can, sit on his couch in his living room and watch, whatever the plant is doing, and nobody needs to be there, right? It will call him when it needs help.
Right.
And that sort of thing has become very pervasive. I will say that the CIE conversation, and from my perspective, has stopped some of that over automation, and it's made people appreciate what I'll call the best of the old ways, which is being able to fall back on manual operations, which is just operational excellence. Building those
Sure.
capabilities in, which is better engineering decisions, but then also just teaching our younger operators and our younger staff that they can't just sit at a screen and operate the system. They have to get out there. And the best operators, they'll walk out on a plant floor, they'll be in a process area, and they'll start looking around and they'll be like, something doesn't smell right, or that pump is vibrating funny. I got to look into that. They really know their environment and their system. And I've just heard all sorts of wonderful stories from around the sector about that level of expertise.
Right.
And it's super important when we're talking about cyber informed engineering, the principle of active defense, and a lot of the other conversations around CIE.
This is maybe more my personal lack of understanding of
Sure.
engineering, but is the message or the approach around CIE different for different types of engineers, mechanical engineers, electrical engineers, so forth?
Oh, that's an interesting question. So I would say that it's probably, within their individual discipline, certainly it's different whether you're electrical or mechanical, but I think the concept is the same. And, all of the infrastructure is really being built to provide water service or provide wastewater service. So as you take the very top view, the consideration and the approach is the same. um, I will say though that oftentimes in our sector, if you are building a new water treatment plant, the engineer who is stamping and sealing the full set of drawings and specs, which is years of FTEs worth of work for many
Hmm.
facilities, is a civil engineer. And most civil engineers are so far away from the control system that I'm a civil engineer by degree. We don't really understand how failure modes can be caused through that control system yet. We are getting better, but it's definitely taking some convincing. Um, and engineers, we can be a little slow to change at times, and I'm looking in the mirror when I say that. But I think the change is occurring.
I wanted to talk about a slide you had at your presentation at S4.
Sure.
They were your CIE principles, and I thought there were a lot of interesting points in there. The principles, just from a high level, are around dependency between systems, visibility of assets, the supply chain, resilience, information controls, culture, etc. Um, just from a high level, kind of why you landed on those, and which ones are kind of like really stand out to you as super important from a safety and cybersecurity
Mm.
perspective.
Yeah, so you're referring to the 12 principles of CIE, and those can be found in the Cyber Informed Engineering Implementation Guide with extensive discussion around those. Now, whenever we talk about these principles, the first one is consequence-focused design. And the key question there is, how do I understand what critical functions my system must ensure and the undesired consequences it must prevent? This is the first principle because it's really considered to be the first among equals. As
Right.
we've gone out and done CAE, we've found that there are people doing all sorts of adoptions, and they're starting in different places, and that's fantastic. And we can get into that later if you'd like. But consequence focused design is really about the mission of the organization, the critical functions in the water sector. That's usually, you know, treating water so that it's safe to consume and use at the right flow rates and pressures, and then collecting wastewater safely and discharging it to the environment safely. If that's probably Those are probably the critical functions for most of the sector. So if you think about those, how do you ensure that those occur, and what are the consequences that you have to prevent related to those critical functions? The next one, engineered controls. So the electromechanical relay example I provided earlier in the conversation today is a wonderful example of an engineered controls. And one of the things that we've heard as we've been working through a current project with the lab around helping organizations adopt CIE is that people are really hungry for engineered controls examples. And this is something
Mm-hmm.
that the lab is currently working on. We're just tangentially involved in that. So those are really the two places to start. Now, we do have to really think about, what are we trying to do? And what I mean by that is, where are we in the engineering life cycle? Because you can have a big old water system, and you can have some things that are in the concept phase, and you can have some things that are in the operations and maintenance phase. So consequence-focused design and engineered controls are going to be most efficiently applied in the concept and design phases, because it's most of the cost of projects is incurred post-design, right? Construction,
Mm-hmm.
commissioning, operations, etc. So you want to get that sort of stuff in early. But what we find is that if you have a big system or a system that you're operating and maintaining, maybe it's going to take you some time to figure out those engineered controls, but I bet you can talk about active defense and um, the concept of planned resilience. So when we think about active defense, which the key question there is, how do I proactively prepare to defend my system from any threat? And planned resilience, which is, how do I turn what ifs into even ifs, which is a fantastic question. That's when we start to get into the thinking around a day without SCADA or a day without automation. And
Right.
you really get to engage the operations staff and understand what their current capabilities are. Oftentimes, when we do these exercises and we have a set of improvement projects in the after action report, a lot of times it's training. So these are operational things that can be done relatively quickly. They can be done in a relatively distributed fashion. And by that, I mean, hey, we have health and safety tailgate sessions. Why not have, one day a week, have a day without SCADA session, right? You take the new operator out, you go to a process, and you say, let's actually talk about this. You get your OT expert out there and you say, what is this PLC actually doing? Right? And you build that understanding and capability really quickly. Um,
Mm-hmm.
so we've only talked about four of the principles, and active defense is actually, which I mentioned but didn't talk about in detail, is actually one of my favorites, because every utility, from my perspective, should have two pieces of awareness that really go into this. One is, there should be some understanding of threat intelligence. So um, the EPA, CISA, some of those organizations do a really great job of providing insights into what's going on out in the wider world, outside the fence. But then also, I really promote the use of network monitoring within active defense, so that the IT OT staff can say, "Hey, operators, something funny is going on here. Take action." And you know, that one, it's and that also goes back a little bit to my example about the really seasoned operator who can go out on the plant floor and understand something is wrong. Right? To me, that is good operations and maintenance, but it's also active defense because they know their process so
Right.
well. So all those elements come together, and it's really, the best of the old and the best of the new within active
Mm-hmm.
defense. Um, if we look at things like secure information architecture, layered defenses, a lot of those things have been well defined via, the Purdue model and the iterations and evolutions on that. Um, Cybersecure supply chain controls is something that I think we desperately need, but it's a little bit amorphous yet. And for most water utilities who are not large IOUs like in the electric sector, they don't have the purchasing power to really drive a lot of change in their suppliers. So one of the things I like to advocate for is, hey, you may not get any changes for a couple of years, but call up your SCADA provider, your PLC provider, and tell them you want things better. And if there's
Hmm.
enough demand signals out there, those providers will see an opportunity and say, okay, let's go and do better. And I think that those OEMs and the software providers are doing a better job. But again, it takes a lot of time.
Yeah.
Engineering information control, we have seen so much information be released out into the public sphere. One of the things I always like to do is use an LLM, Perplexity, for example, and just say, hey, what type of PLC does utility X use? And sometimes it tells me. There was actually, after my S4 presentation, a gentleman came up to me and he said, so I went to Perplexity and I asked it what kind of PLCs I use, and it told me. And he just kind of
That's
slumped his shoulders and
horrifying.
walked away. And I felt so bad for him. I talked to him later, and he's like, "Oh no, my OT people are on it. They got it." So that was good. And of course, culture, right? And part of that culture component is change around cybersecurity, cyber resilience, and ultimately integrating CIE into the day-to-day practices.
Right. The more I read about this as a concept and hear you speak about it, it's dawning on me that this might be one of the best examples of bringing cybersecurity to non-security teams, and it really talking their language, for lack of a better term. I mean, and that's always been kind of a place where enterprise security, information security has struggled, and I think you guys have cracked the code here. I mean, do you agree? Do you ever think about it
I,
on
I
those
I
terms?
think you nailed it. And part of the reason is that when we go in and we talk purely about cyber hygiene, it's it's intimidating to people. It's stuff that they don't really understand. It's oh, excuse me. It's really IT's problem. And what we've managed to do in these conversations is we've expanded the understanding of what cyber informed engineering is, who owns the risk, who's responsible for managing the risk. Some of it's on the
Mm-hmm.
engineers and operators now. But, and that's all kind of like, hey, engineers and operators, you need to get better. But the reality is every time we go into an organization, they're already doing something CIE-esque really well. For example, I was working for a small utility in the San Francisco Bay Area, and we had this conversation with them about a day without SCADA, and they were like, our SCADA system has never really worked, so we just call that Tuesday. It's like, fantastic. That's a great way to start with some planned resilience, right? And
Yeah.
active defense. And so, CIE allows us to build on the good things that they're already doing, as you mentioned, using some of their language. And so instead of it being like a 180-degree, shift for them, it's like 3 to 5 degrees to start with.
Right.
And over time, that
Right.
shift will get better, but it'll be done incrementally, and it'll just be a lot easier to implement that change.
So, just a couple of implementation questions. Like, how would an organization know they're ready? I mean, what has to be in place, or what skills might be required? Even buy-in. I mean, how important is buy-in from execs, et cetera?
Buy-in from executives is always important, and creating any type of sustainable program it really requires that. So we're doing this current project for the lab about CIE adoption pathways, and we're really trying to articulate some of these things very clearly so that when people learn about CIE, they don't get stuck in a delay or in action mode because they're just overwhelmed. And so we're trying to boil it down a little bit. Through that process, we've collaborated with about 25 subject matter experts from across sectors, across roles, and across different types of organizations. And so, what we have found is that to some extent, where an organization starts is going to depend on who wants to start it. So, if it's an engineer, we're going to probably start in the engineering design process, and we've actually done that where we tend to hold up the value engineering process, where at each engineering milestone, a value engineer comes in and tries to trim the fat a little bit. And what we have done is, in parallel with the value engineering process, is done a CIE review. And this looks a lot like,
Yeah.
A red teaming of the design, but from an engineering and operations perspective. It's not about getting in, right? We assume we're in. Now we say, what can we mess up? And that's been a really good exercise. One of the things that we were doing initially when we started this is we were just doing engineering reviews, which was
Right.
great. We're engineers, we're used to it, so we just sort of fell into that neural pathway. One of the things that we learned is that we kind of had to construct our team a little differently, construct it like a red team, construct it like an attack team. And one of the concepts that I brought up in my S4 presentation was this idea of commander's intent. Now, I never served in the military, so when I thought of this, I thought it was fairly novel, and then I said, I bet somebody else has thought this up already. But I step into these red teams as the commander, and I say, here's our intent. I think you can break this system here, here, and here. Tell me how you're going to do it, or tell me you can't do it, and we'll adapt our attack plan. And that actually provided a really nice structure for the interdisciplinary engineering team. It also provided a really nice way for communicating with the client, because all of a sudden, right, we did a red teaming of the design. Now we're talking with them about it. So we're pulling them into the team and getting their system specific expertise. And it turns into a
Right.
really positive conversation instead of us saying, you should fix that, and you should fix that, and you should fix that. Right? It's really fun. And so, one place to start is within that engineering design process. Another place to start, and I'll be honest, 2 months ago, I would have been very skeptical of this idea, but within the current CIE adoption pathway project, I spoke to a gentleman who did OT cybersecurity for like Fortune 100 companies, right? Massive organizations across the globe. And so he would come in to a facility and he'd say, all right, we're going to do CIE. And, he really can't start at the consequence phase because his expertise is OT cyber. Also, the people he's engaging with are not, the leadership of the facility or the leadership of the organization. So it makes some of those kind of base conversations more challenging to have. But what
Right.
he figured out was that he could easily go in and start with digital asset awareness, right? Oftentimes, that's what he was being hired to do. So he would recast some of the things that he was doing and build on those to, as the key question is for that CIE principle, how do I understand where digital assets are used, what functions they're capable of, and what assumptions are we making about how they work? And so through that principle, he was able to bring CIE to his customers in a way that, like I mentioned, I wouldn't have predicted 2 months ago
Right.
because I come at this from an engineering perspective.
And one more kind of implementation question: is there a checklist of outcomes you should hope for, or milestones?
A lot of people ask for checklists. Engineers love checklists. I'll be honest, Michael.
Yeah.
And so that's definitely something that we're expecting. Now, we have a book coming out in July. It'll be published through the American Waterworks Association. It's called Resilience Through Cyber-Informed Engineering: An Engineering and Operations Approach to Cybersecurity. So, long title, but what we lay out in there is, to some extent, the beginnings of what could become a checklist over time. It could become a manual of practice. It could become all of those things.
Yeah.
Interestingly, shout out to some of my colleagues at the Idaho Department of Environmental Quality. So, to go back about a year, actually, they had started to learn about cyber-informed engineering, and they manage the grant process for the state revolving fund, which is how the federal government and state agencies provide grant funding to the water and wastewater sector for improvements and planning and all those sorts of things. they managed to take CIE and weave it into their grant funding process. And so as
Oh,
part of
wow.
that, they've gotten a lot of questions from the applicants. Like,
Hmm.
we see what CIE is, but we don't know the how or the what yet. And so at the design level. And so they have actually gone and they're starting to build out some really good examples. And I think that, between our book, what they're doing, some of the things that the lab is working on, let's talk in a couple of years, we'll have some checklists. For right now, though,
Right.
a lot of organizations are going to be, to some extent, figuring this out as they go, which is part of being an early adopter.
All right, Andrew. I think that's a good place to leave it. I
Cool.
really enjoyed this conversation. I think you've brought a lot of information to the table and given people a lot to think about. So
Wonderful.
it's exciting. I hope it really kind of ramps up, and I'm glad to see there are folks at the forefront of this.
Yeah, it's really exciting. Back when I, first met Andy Bachman and we heard about the things that the lab was doing, as I mentioned, it was an aha moment, but it was also one of those rare moments in my career where I said, oh yeah, I'm going to go do that. And so 6 years later, almost to the date, to be doing this and talking with you here and being in the mix, trying to figure out how to actually make this work, it's just, it's a privilege. And I really, thanks for the opportunity to come on and speak with you about it.
Absolutely. I know that our audience is going to love this, and I'm sure we'll get some engagement, some question on social media and through the site. So looking forward to it, and hopefully we'll do another one down the line and kind of update folks on where things stand.
That sounds great. I look forward to it.
All right, Andrew. Have a great day. Thanks.
Thank you, Michael.